Example: drawing marbles from a box with replacement. Suppose that a box contains three red marbles and 7 blue marbles. A marble is drawn at random from the box. Its color is noted and it is replaced back in the box. A second marble is drawn from the box and its color is noted. A. What is the probability that the first marble is red? Okay, so what happens is you have this box, and in this box are 3 reds and 7 blues, which has a total of 10. So the probability of red is just the number of reds, which are 3, divided by the total marbles in the box, which is 10, and that makes 0.3, which is 30%. So this is just drawing one marble. Now after you draw the marble, you put it back in the box. Some of the problems say tickets. Sometimes I get mixed up on whether I'm using tickets or marble. But anyway, you have a box with tickets or marbles in it. Okay, tickets are usually when you have numbered tickets in the box, and then if you have colors and it's marbles, it's all pretty much the same thing, same idea at least. What is the probability that the first marble is red and the second marble is blue? Okay, so what we're going to do again is just draw the same box here. We have 3 reds and 7 blues. So then we get the probability of red is again 3 out of 10. Now we take the red out and we put it back in, and you're going to get the same box. So this is the probability blue is 7 out of 10. So what we're looking at is the probability of red then blue is what? It's the probability first that you get a red and then that you get a blue, given. That's what this means, given that the first is red. But these two events are independent. What does that mean to be independent? It means that it doesn't matter one bit whether on the first draw you drew a red or a blue. Why? Because we're going to put the marble back into the box anyway. So it doesn't matter. The first and second drawings are independent because the outcome of the first drawing does not affect the outcome of the second drawing. So that's a very important word. They're independent. Okay, let's move on to another one, C. What is the probability of drawing a blue and a blue? So the probability of blue, blue. Well, you have the same box, which was 3 reds, 7 blues. And so the probability of blue, blue is the probability that you get a blue on the first one, and then the probability of blue, you get a second one. So, all right. Why is this true? Because, why do we multiply these? You can think of that out of every time you draw a marble out, 3 out of 10 times we draw every time we draw a marble out, 7 out of 10 times we get a blue. And out of those 7/10 times, on the second drawing, how many, so you have 3 out of 10, you're going to get a red, 7 out of 10, you get a blue in the long run. And out of those 7/10 you get a blue, 7/10 will get a blue on the second time. So this is 7/10 will get a blue the first drawing in the long run. Out of those, 7/10 of the 7/10 will get a blue. So that makes 49 out of 100, which makes 49%. The probability of 2 events occurring is the probability of the first event occurring times the probability that the second event occurs. So that's why we multiply them together. So this is multiplication when you have probabilities. Multiplication is when you have 2 events and you think of one happening first and then you have another one following. It might seem like you're doing them both at the same time, like if you're tossing if you're tossing a coin, or especially if you're, say, rolling a pair of dice. But the way when you roll a pair of dice is you can think you roll one die, and then another die. That's one way to look at it. So whenever you have 2 events, you look at the probability of the first and then multiply the probability of the second. Now, in many cases, the second event, the outcome of the second event depends on what happened on the first event. In this case, it doesn't make any difference what happened in the first event, because this is with the replacement. We put the marble back in. What is the probability that the first toss is blue and the second, actually it's not toss, it's drawing. is blue, and the second drawing of the marble is red. So we're looking at the probability of first a blue, then a red, and we have the same box. There's 3 reds and 7 blues. So this is going to be the probability you get a blue the first time, then the probability of a red given that you have blue. But the thing is that, again, they're independent events. Whether you get a blue the first doesn't make any difference with getting a red. So we just have the probability of red. So the probability of blue is 7 out of 10. The probability of red is 3 out of 10. And that makes 21 out of 100, which is 21%.